So my name is Rahul, and I'm a principal engineer at a hedge fund slash VC firm called Code Management. So today I'm really excited to share with you guys a dream project that I worked on for the last 4 months. So this is Compile AI, and this is an AI framework to generate code based on natural language input. So at a high level, let's say you have a product requirement that is in English, or you might have a programming contest problem that you want to solve. So I want to take those problems and generate code for that automatically in Scala. So I know this is a big goal, but let's see how we can do it. So why is auto code generation so important? Because let's say like you're a product manager and you want to develop something really fast. You can, instead of going to the developer, you can as well go to the AI and ask the AI to develop the code for you. And yeah, like about the developers. So when we went to school, like what did we learn? Like we didn't do like all the problems that are out there in the world. We just learned like pretty much the basics, like how do we do backtracking, how do we solve the problems with like CSP, constraint satisfaction problems, or it could be like dynamic programming and things like that. So like we learned all the basics. So my idea is why don't we teach the AI like how to deal with a problem and try to generalize it and let the AI code for us instead of we coding the AI. So let's say like we come up with an AI to do something like this. It can do a much better job at writing the code because let's say it wrote a function. It can probably write like hundreds of test cases for it, and you'll have like much better quality. And at the same time, it can do it at a much faster pace because it can like much faster than any of us. Okay, so let's talk about the state of the code generation. So the University of Washington guys, they came up with this tool called Telina, wherein you can command your terminal with your natural language. So essentially, like you can say, hey, find the PDF in XYZ. So this is the query that I gave it, and it created something wrong, but you get the idea. Like you can give a natural language query, and it'll try to come up with a command line for it. Okay, so Salesforce recently came up with an AI wherein you can command your database with a natural language. For example, in this case, this guy has a question in a natural language, and like it is able to generate a SQL query. Okay, pretty cool. Now, Microsoft has done a lot of research in this area. So they already rolled out like several features, like flash fill and flash extract. So let's say like in Excel sheet, you have a column, and you want to write another column that is like a formula on top of the first column. You can give like one example and do like a special command, and that will fill out the rest of cells in the second column. And so sometimes like it can do wrong things, wherein you have to provide like more examples so that it knows like what you are trying to get at. So like the interpretation could be like so many things. So as you give like more examples, it will try to come up with the right algorithm for you. So you guys should check out this video like whenever you have free time. Okay, so what are the limitations with the current approach? So like program generation is like a search problem. So you have like millions of possibilities that you have to search across in order to generate the right program. So people tend to use some kind of DSL so that like you can limit the number of possibilities. For example, like the state-of-the-art research done by Microsoft, they have like 20 functions, and so if the DSL works well for that program, it works fine. But if something like if you have to write a program that can't be written with a DSL, it doesn't work. And because of this, like everything tends to be like domain specific. For example, like we saw a terminal command, and we saw a SQL command, and we also have a limited set of DSL in most of the cases that I have seen. So the problem that I'm trying to solve here is I want my DSL to be natural language. So that is one primary goal. And I want the bindings to a Turing complete system. So in this case, Scala. So essentially, I'm compiling natural language into Scala. And the grander goal is like I should be able to compile to any language. So let's see like how we do it. So this is a problem that I took from Euler problem set. So this says, hey, find the sum of all the multiples of 3 or 5 below 1,000. And this is a solution that the AI came up with. So I'll do a live demo so that you guys know like what I'm talking about. So if you go to the Compile AI website, you'll see the same material, but I have disabled the program there so that I can do the demo. I'll enable it like once out of the demo. Okay, so this is the Euler problem one. So find the sum of all the multiples of 3 or 5 below 1,000. Okay, so what does this sentence mean? So it makes like a lot of sense to you and I, but like how can you make sense to the computer, right? So in the natural language processing domain, like we have the dependency parse trees. So that will essentially capture the meaning behind the sentence. So here, the same sentence written out as a parse tree. So here, like I'm trying to find something which is sum, and sum of what? Sum of multiples, and multiples of what? 3 or 5, and given a condition that it is below 1,000, like all the numbers are below 1,000. Okay, so this makes sense. So how do we convert to Scala? So this is a solution, the Scala solution for this problem, where and if you generate the Scala AST tree, it looks something like this, like pretty much the same structure, but different operations. So let's take a look at this one. So here, the below 1,000 is is that good? Good? Okay, anyways. So this is a natural language tree, and this is a Scala tree. We are essentially saying, hey, below 1,000 should be mapped to something like 0 until 1,000. And the left-hand side here, the multiples of 3 or 5 should be mapped to the right-hand side here. Okay, so how do we do that? So I came up with some toy rules, so just for the purpose of this demo. So essentially what I'm saying here is, so let's say like you see this English word plus, and there is a param to the left side of it, and there is a param to the right side of it. How do we convert that to Scala is literally the plus sign, just put a plus sign. And I'm also doing some type level checking. So I'm also capturing like what are the param types and what is the return type here. And I'll talk about the score as well in a little bit. Okay, so given a grammar like this, how can we generate the program? So let's say you're here, back to below 1,000. So this will be replaced with 0 until 1,000. And but as you can see here, multiples of 3 or 5, it can't be applied directly. So you need to come up with some kind of solution for it. So essentially, like you take the left-hand side, which is a sequence, a collection, and the right-hand side is a filter. So how do you compose these two things together? Or we can ask our friend Scala Compiler to do it for us. So how do you do it? So you can try to get the type of the string here. For example, let's say I have a sequence of 1, 2, 3. I can, using the runtime compilers, I can try to get the type of it, which gives me a sequence of ints. And on the right-hand side, I'm applying a filter, which is into Boolean, for an example. So how can a compiler help us in this case? So you literally ask the compiler, hey, like given this type on the left-hand side, for example, in this case, a sequence of ints, give me all the methods on it. Okay, so it gives you like probably 150 methods. But can all of them be used as a compose function on the with the right-hand side? Probably not. So you can. So then you take the right-hand side type and try to filter all the functions that are listed by the compiler, and that gives you a list of 10 different things. So this way, you need not write like all the possible functions out there in the world. You can literally say, hey, like you can concentrate on the main pieces, which is a plus, multiply. Like you have to teach the AI somehow, But rest of the things like composition and stuff like that will be provided by the compiler. Okay, so there are 10 different possibilities, like which one do you pick? So that is the next thing that will come to your mind. So I have a solution for that too, using runtime macros again. Before we dive into the runtime macros, I want to also give you guys different complexities that we have with the program generation. So for example, like in a natural language, it is inherently like really ambiguous. So sometimes there could be like 10 different parse trees for the same sentence, and all of them could make sense. And another problem is like most of the NLP tools that we have, they don't generate the right parse tree like most of the times, especially for the problems that I'm trying to solve here. So what do? Like we have to take, like instead of one tree, we have to possibly take like 20 different trees and see like, can we generate program out of all these trees? Okay, so that is like one level of complexity. And now another level of complexity is like, although you see the same word like sum, it might mean a plus symbol in certain cases, and it might be like collection.sum in like other cases, depending on like what type you are applying it on. So yeah, like instead of like just a plain translation, you have to look at like multiple possible translations. So this is another dimension. Okay, synonyms. So so let's say you have defined a function on sum, and you don't probably want to define it again on plus, because like inherently they are like synonyms, and you should be able to apply the same function no matter what. So essentially, you can go to the English dictionary and say, hey, like what are my synonyms? And if there is a synonym that has a function defined on it, I can use it. So this is like another level of complexity. So as you can see, like we can generate like possibly 1,000 different cases that we have to scan through. So given this complexity, like how can we use runtime macros for it? So essentially, like I'm trying to evaluate the natural language tree as an expression. So when I go here, so I'll convert this to like 3 or 5, and literally 3 or 5. And I have a function that is being applied, which is a multiple. And multiple gets converted to mod 3 equals to 0 or mod 5 equals to 0. Okay, and if that makes sense, I'll try to see, hey, like I have so this below 1,000 gets mapped to 0 until 1,000. And then I can see, hey, like can I apply this function? And that's how like it gets evaluated until the top. But as we talked before, like there are different possible combinations, and sometimes the parse trees don't make sense in Scala. So like a lot of times, like I run into scenarios where I see things like this. So there is 2 plus 2, and there is 9. So what are we doing with this 9? It doesn't make sense. So the Scala compiler says, hey, there is something wrong with the code. I don't know what you're saying, and we can actually prune that possibility. So this way, like we can prune out like tons of possibilities. So from what I have seen, like most of the programs, like online programs that I have been generating in Scala, like they're like pretty fast. So I'll give you a demo of that right now. So by the way, this is all live code. So all I have is a bunch of rules like this, pretty simple stuff, and see like how it gets evaluated. Okay. So I did 10 plus 2, and this is the natural language tree that got generated. So what are we seeing here? So we see plus, which is the root node, and we have 2 children to the plus, which are like 10 and 2. So how do we evaluate it? So this is literally how it gets evaluated. So plus, can I like when I see this word plus, like can I actually ask the database, hey, like do we have any functions defined on it? And then the database returns plus, and then like I substitute it with plus, and see if it's a valid expression. So this is a pretty normal thing. And as you can see, like it generated the code 10 plus 2. Okay, no big deal. You're just substituting. Okay, and you can do 10 multiply 3. It'll give you 10 times 3. And So I just want to show you guys that I haven't hard-coded anything. It's not like template-based or anything. So for example, let's say, okay, so find 10 multiplied by 3. So here in this case, see here the root. So we started with find, and like 10 is a child of it. But there is no function defined on find. So it is actually moving on to the next one, which is 10. And now I'm at 10. And like, what are the children of 10? It is multiplied. And it doesn't make sense at a Scala level, but it makes complete sense at a natural language tree. So you have to design the code in such a way that, like, given like any types of expressions, you should be able to solve it. Okay, I have multiplied, and then what is the lemma of multiplied? It is multiply, and multiply has children called by. Okay, what is the children of by? It is 3. So that is how, like, it boils down to the leaf nodes, and leaf nodes get evaluated, and it trickles down to the top. Okay, so then this comes down to 10 times 3. And as you can see here, so like when I say multiply, and I give it two variables, it should do 10 plus 3. But if it's a collection, I have to do this, like collection dot map x equals to x dot 3. So this is another possibility that I'm considering here. So like I try to evaluate both and see which one makes sense. So this one throws a compile time error at runtime, and this one looks good. So I'm returning this code. Okay, pretty simple stuff. So if you guys search for the same thing in Google, Google fails right here, like in the third or fourth examples. Okay, so let's see 10 power 2. Okay, so this is the code, math.power. Okay. So till now, it didn't do anything intelligent. I'm just substituting. Okay, the next problem is disambiguation. So let's say you ask your friend, hey, like, what is 10 plus 2 multiplied by 3? So there are two possible scenarios. Like, we know the operator precedence and stuff, but like, you will actually ask your friend, hey, like, did you mean 36 or 60? So, and essentially so there are two possible expressions here. So that's why it tells you, hey, like, there are two possible things, like you can do 10 plus 2 times 3 or 10 plus 2 times 3. So this one leads you to 36 and this one leads you to 60. So which one do you want? So here, like, you can also give an example and say, hey, AI, hey, this is what I meant. So you can give a sample case like this. You can say, this should evaluate to 36 in this example. You can say something like this and try to run it. See, now it gives you one example. Isn't this cool? Okay, so I'll get on to more exciting stuff now. So till now, we dealt with 2 variables, 3 variables. Okay, no big deal. Now, so just to tease your friends, you can ask them something like this. What is 10 plus 2 multiplied by 20 plus 38 power 3? In a real life, you wouldn't ask this question, but AI can answer like all these things. You can do crazy stuff with this. Okay, let's see what the AI says. Okay, so looks like it computed 2 different codes. So you can play with it. So I'll put this online, like once I'm done with the demo. So like whenever you have time, you can just go to compile.ai and you can play with it. It is live. Okay, so now we dealt with like basic math expressions. Let's get on to loops. So it's like any programming tutorial that you guys find for any language. It's just that this is a programming tutorial for the AI. Okay, so Again, the same thing, you found the tree and you're evaluating everything, and ultimately it found two different, so the below 1,000 can be treated as less than 1,000, or it can be treated as 0 until 1,000.toList. So in this case, this one makes sense. So, and at the runtime, like I'm checking, hey, like, does this expression less than 100 make sense to me? And to the compiler, it doesn't make any sense, so I'll throw it away. So this is how like I prune like a lot of different possibilities at each and every level, and that's why like it's like super fast. Okay, no big deal. Okay, so now conjunction. So this gets interesting at this point because from this point of view, like you have to start adding code in the AI modules. So for example, like I added a conjunction module, which will take like expressions like this. So 2 or 3, and I'm like whenever I see an expression like this, I convert that to an expression like 2 or 5, and I apply the like whatever is onto the left-hand side of it, which is a multiple. And so here, like I wrote a code in such a way that like whenever I see an expression and I'm applying a function on top of it, it boils down to like a real or an and. So this is conjunction. So let's see like how this looks like. Okay, wow, a lot of logs. Okay. So as you guys can notice here, so like we never defined like all these functions like span, drop while, take while, but the like we're, as I told you before, like the compiler is actually solving it for you. Okay, but only some of them make sense. Like in this case, only filter makes sense. So you can say, hey, like I actually want the filter part. You can say like, hey, this is the value that I need as an example, and it'll boil down to like one particular solution here. Okay, then you can actually do the actual first problem. Oh. Okay, let's see what's going on. So it generates like a ton of possibilities. So anyways, like you guys can play with it. So I'll just try to wrap it up. So essentially, like what we are teaching computer is a bunch of strategies on how to do things. So here, like I have some strategies wherein I can teach, hey computer, like this is how we apply divide and conquer. Like for example, like in merge sort, what do we do? Like whenever we see a collection and we are applying a function on top of it, we break it down into 2 chunks, and then like we sort out, we merge the results together until we get to the end. So this is like a template that I used. And this is another divide and conquer algorithm that I taught it. So essentially, this is like mathematical induction, like a Fibonacci series kind of thing, which you can also teach the computer how to do it. So like right now, I'm working on codes like where I can apply the constraint satisfaction problems on like n queens or like Sudoku puzzles and things like that. So till now, like we have limited the AI to be like working on a specific set of rules that you have given in your database. But imagine like what it can do if you let it like pull the learn from the online stuff. For example, it can go to GitHub, or it can search on Google.com and try to understand all the things. I think it'll be an amazing product like sometimes down the line. I think we are pretty close to super AI pretty soon. Okay, that's about it, guys. Thank you.